And welcome back. It is the 7th of June, Further Maths 5 a day, and let's just go straight to the first question. Right, first question says, find the equation of the circle. So for an equation of a circle, I need a centre and I need a radius. Well, the centre, I can see from the diagram, is 3, 4. So I'm going to write 3, 4, just to make a silly error. And the radius is 1, 2, 3 squares across, so it's 3. So in other words, nice and straightforward, x minus 3 squared plus y minus 4 squared is equal to 3 squared, which is equal to 9. First question done. Next question. ABC is a straight line with A to B, B to C. All right, so I'll split into 2, 5 to 2. So that's 5/7, and that is 2/7. Work out the coordinates of B. So I'm going to use my vector approach. Now, hopefully, if you watch a few of my videos, you're quite good at these vectors now. I know people don't like vectors to start with, but genuinely, they're really helpful. Either way, to get from A to C, so minus 11 to 45 is 56. And 40 to 19 is minus 21. Now, what's notable about these, both these numbers divide by 7, which makes me feel a bit better, because A to B is 5/7 of this. So I'm going to write it out. So 5/7 of 56 minus 21, which is now 56 divided by 7 is 8. 8 times 5 is 40. That's 40. Minus 21 divided by 7 is minus 3, times by 5 is minus 15, which means I have my vector to get from A to B. But that's a vector, it's not a point. So therefore, in order to work out my point, the point B is going to be, well, it's minus 11 plus 40, and it's 40, so this 40, so different 40. So this 40 minus 15, and that gives me a final answer of 29, 25. And quick check on the diagram. I mean, it's not brilliant, but that kind of looks okay, doesn't it? I mean, kind of looks okay is not maths, but it doesn't look unreasonable. Next question. A curve has equation, gives me an equation. Find the gradient of the normal, so it just wants the gradient at the point here. So actually this one's not too bad, is it? So y equals 2x minus 6. At x equals 1, that means the gradient is 2 times 1, which is 2, minus 6, which is minus 4. So the gradient of the normal, negative reciprocal, is a quarter. Question done. Doesn't want the equation, just wants a gradient. Next one. Given tan theta equals this and theta is reflex, work out the value of cos theta. Well, the first thing I'm going to do is I'm going to note that tan theta is opposite over adjacent. So in other words, this here, it's what's known as a 7, 24, 25 triangle, but let's work it out. This here is 7 squared plus 24 squared, square rooted, which is 25, which means that cos theta is going to be equal to adjacent 7 over 25. Now, the thing I haven't worked out, is it plus or minus? Let's look at the tan curve. So the tan curve looks like this. So that's 0 to 180, and then 180 to 360 is this bit here. Now, because it's reflex, I know it's in this part here. And because it's negative, I know it's greater. In other words, I know it's in Q4. Now, in quadrant 4, cos, try and get this right. So cos, get it right around. So cos looks like horrible cos. The point is, it is positive. So therefore, this is also positive, which my answer is 7 over 25. Good question, that. Next question. Given that this is prime, show that this is a multiple of 3. I think I know what to do. Multiple of 3. 1, 2, 3 consecutive integers. It tells me this is prime. So this number here is 2 to the 89 minus 1. If I add 1, I get 2 to the 89. And if I add 1 again, I get 2 to the 89 plus 1 plus 1. So far, so good. Now you're going to make the argument. So again, the examiner is just looking for you to know what to say. You don't have to write an essay. So this is prime from question. I've kind of left this in the back. Let's move this down here so it's not in the way. So from the question, I know the first number is prime because it told me. This is divisible by 2 because it's 2 to the power of something. So therefore, now, if you have 3 consecutive numbers, so 3 consecutive numbers, I suspect it wants you to say that explicitly. Thus, divisible by 3 as others are not. So the idea is, let's pick any 3 numbers. So pick a number, let's say 87. So 87, 88, 89. One of those numbers must be divisible by 3 because if I have 3 numbers in a row and every third number is divisible by 3, one of them must be. That's the argument I'm making. So what I'm saying here is it's told me this one isn't. It's told me this one, actually I know this one isn't because it's power 2, so therefore it must be this one. That's my argument. And that is it. That's a difficult question at the end, but good, not unreasonable question. Let me know how that went for you. Did you get the one at the end? If you did, well done. As ever, like, subscribe. See you tomorrow.